Good morning, teachers. Welcome to another episode of Experiments with Wacebo's Science Bus. Today we are going to study the electricity kit, and in particular, we will carry out a fundamental experiment for the study of electrical circuits. We are going to see how to test Ohm's first law in a practical and very hands-on manner. In this experiment, we are going to make the definition of Ohm's first law far more concrete. That is, we will try to demonstrate how the electric current is directly proportional to the applied voltage and at the same time inversely proportional to the resistance. We will do it in a visual and hands-on way by changing the various components of our circuit and seeing directly on the multimeter how the result changes. This is a very direct test to see how the mathematical formula actually works in practice. To carry out this experiment, we will need the baseboard from the electrical kit, the digital multimeter, the voltage generator, so the 1.2 volt battery, and then you can provide yourselves with a range of several different resistors. We will also need the various pieces of wire in order to assemble our circuit correctly. Let's go ahead now and set up the circuit properly. Then we go ahead and set up our multimeter so that it can take current intensity readings properly. Please note that the red lead must be connected to the milliamp socket and the black lead must be connected to the socket labeled COM. This is because obviously the current voltage is very low, minimal, so we will measure it in milliamps. Let's now switch on the multimeter and set it to the 20 milliA setting. In this way, we will be able to measure the voltage in an accurate manner. So we set the full scale range to 20 milliarc, and we notice that as soon as we close our circuit, the multimeter shows us the current intensity that has been measured. If we now apply Ohm's first law to 1.2 volts divided by 2.20 ohms, we can quite clearly see that the result comes out to 0.054, naturally expressed in amperes. So if we then convert this value from amperes into milliamperes, we obtain precisely the value that is shown here on the multimeter. Clearly, there is a slight discrepancy in the decimal places. This is simply because we are working in a real-world context, so we inevitably have a small margin of error in the measurement. Now we can continue with our test by adjusting the resistance and observing how the current changes accordingly as well. So with 470, I'm going to reapply Ohm's law once again, and I can quite clearly see that the result really does indeed check out. With 100, so obviously by dividing by 100, I just need to move the decimal point, in fact. And here we go, we indeed get 2.20. We always have this 0.2 difference between the mathematical calculation and the recorded measurement. We probably have a battery that may be slightly above 1.2 volts. Now let's try it with 1000. You just move the decimal point 3 places. If we want to, we can also go ahead and carry out a further test and add in an additional voltage source. In this way, we should be able to observe that the current doubles because by doubling the voltage, the current should also double. Let's now take a moment to see whether this actually happens. And here we have the current doubled. This is an experiment that helps all students, especially those who find it difficult to visualize the mathematical side of science. To continue discovering more experiments on circuits and the electrical kit, keep following us here at Experiments with Wacebo's Science Bus.